You might have heard about AMD's AFMF feature recently, that being AMD Fluid Motion Frames, which, yes, means saying AMD AFMF is like saying rip in peace. AFMF is heralded as the one-click way to double your frame rates in basically any game. But what actually is, or what are fluid motion frames? Well, in short, it's frame generation. The same idea as NVIDIA's DLSS frame generation, but it's done in the driver. That means that, much like Radeon Super Resolution, the game doesn't need to support AFMF or frame generation at all. In fact, the game, and even performance monitors like FrameView or OCAT, won't know anything about the generation happening. Now, it does have a few limitations. It only works on RX 6000 or 7000 series cards and 700M graphics on APUs. I'm testing with an RX 7600 here, and something I only found out after starting to test, it only supports DirectX 11 and 12 games. No Vulkan support, which means Rainbow Six Siege does not work. Strangely, even when I launched Siege in DirectX 11 mode, it still said it wasn't supported. Perhaps AMD just blacklisted the Siege EXE, who knows. But for a plethora of reasons that I'll explain later, I switched to Starfield instead. Oh, and it's worth noting that you're meant to have both HDR and VSync disabled for this too. Right, let's look at some data. First, as a baseline, I tested the system with just Radeon anti-lag enabled. It's a feature I would recommend enabling regardless of any other settings, assuming you have an AMD GPU anyway, so I'd consider that a fairly baseline setup. The next test was just turning AFMF on, so the only two AMD features enabled were anti-lag and AFMF. Lastly, I also enabled their new HyperRX mode, which turns on every tool in the toolbox, including things like Radeon Super Resolution. As for recording data, for latency, as always, I'm using my open source latency testing tool that I developed and sell over on osrt.com, by the way, link in the description. And for FPS, as mentioned, tools like PresentMon and FrameView, which is just PresentMon with an NVIDIA wrapper, won't detect the total performance here, so I'm using AMD's own driver-based performance monitor. One extra advantage of that is that it'll also report how much latency the frame generation is adding. So I've included that data here too. So what's the results? Well, if we look at the performance data first, you can see how effective AFMF really is. We go from 104 FPS average to a whopping 166 with just AFMF enabled, and enabling HyperRX and all of those other features like RSR on top gives you another 10 FPS or so. And it actually gave a significant boost in the 1% low results too, a full 30 FPS higher here. Clearly enabling AFMF is a no-brainer then, right? Well, if you notice that extra number at the bottom there, the frame gen latency average, that's pretty important. Obviously, with no frame generation enabled, we're adding zero latency to our gaming experience. With AFMF enabled though, you're looking at 20 milliseconds of added latency. If you've watched any of my latency guide videos, you'll know that 20 milliseconds is an awfully long time to be adding on top of the game itself. Let's look at the latency results in fact. As expected for a game that isn't running overly fast, even on a 165Hz display, 100 FPS means new frames are every 10 milliseconds or so. And so it looks like Starfield on all low settings with FSR2 enabled takes about 3 and a bit frames to render an input. That's pretty slow as is, but when you add AFMF on top of that, you end up with a frankly appalling 59 milliseconds of average delay between giving an input to that input being shown on screen. For a game like Starfield, it's a genuine toss-up whether the improved smoothness of the artificially increased frame rates is worth it over a doubling of the input delay. The big problem here is that the higher the latency, the harder it is to aim with any accuracy. If you spend most of your time in the dialogue options and running away from fights, AFMF is the tool for you. If you want the competitive advantage in a gunfight, you might want to switch AFMF off. Now, I was going to leave it there and move on, but in the interest of thoroughness, I tested 2 more games to see how they handle it. The first is the other super intensive single player game everyone loves to hate, Cyberpunk 2077. On the medium preset, which uses FSR 2.1 by default anyway, unsurprisingly, AFMF and the HyperRX mode offer significantly better performance than without. Like, this is a 60% improvement on average. Impressively, this RX 7600, even at 1440p, still offered 121 FPS on average, but it's very obvious that you get a smoother experience with AFMF on. Interestingly, likely thanks to the frame rates being pretty similar, the frame gen latency is about the same, this time around 18 milliseconds on average. That's confirmed when we look at the latency chart too, where the stock results are a reasonable if kinda slow 28 milliseconds on average, versus both the AFMF results at an astonishingly sluggish 54 milliseconds on average. This one, at least on this 7600 on the medium preset anyway, is a little harder to justify. Cyberpunk relies a lot heavier on gunplay and action, and how even just trying to drive with double the latency just isn't going to be a great experience. If you care more about visual fidelity and are so more likely to be playing on a higher setting and therefore lower frame rates, then I think that tips the scales in favour of using AFMF. Lastly, I also tested CS2. I was almost certain that this would be a wildly different set of results and conclusions to Starfield and Cyberpunk, but honestly, I couldn't have predicted the results I got. Starting with the FPS data, it looks like AFMF made the gaming experience considerably slower. Like, we lost over 100 FPS on average here by turning AFMF on. We did gain a bit of stability, bringing the 1% lows right up to the average, rather than around half the average with AFMF off, but losing performance isn't a great sign. I have to assume that part of that has to do with the frame gen latency figure. 11 milliseconds is way too high for a 2 millisecond frame time. There was clearly a decent bit of time taken to analyze and render the fake frame and then display it. And all of that work is for naught, because not only do you lose performance, your inputs take nearly 3 times longer to register. We go from an average end-to-end latency of 9.7 milliseconds, a fantastic result, to 25.9 milliseconds, which for a game like CS2 is a death sentence. These 2 graphs should be all the evidence you need to not use AFMF or HyperRX with CS2. Don't do it, just don't. It's worse in every single way. Okay? Got it? Good. Now, something I want to take a second to explain is why these features, whether they come from AMD's open source arms or NVIDIA's proprietary claws, will always add latency. It's a fundamental function of how they work. Basically, to be able to generate a somewhat useful intermediary frame, it needs to be able to look at the current frame and the next one. Let me visualize that here. So we've got the current frame that's on its way to the display. That's all ready to go. Now, any type of frame generation feature, AFMF, DLSS frame gen, it doesn't matter. It has to wait around for the GPU to draw the next frame. Then, instead of just pushing that new frame straight out to the display, which is as low as latency as possible, the FrameGen tool then compares the two frames and renders an in-between frame. That will take some time to do, as we've seen from the data, and then it will send the fake frame out to the display, and then after all of this time waiting, the next frame actually gets shown. The fact that these features have to see what the next frame looks like to interpolate between them to create an extra one in the middle means that these features will always add latency, and the only optimization here is how quickly they can do that interpolation. That's why even NVIDIA's in-engine version takes just as long. Interestingly though, there is one key design choice I'm yet to talk about here, which is that AMD has chosen to disable AFMF during fast movement. Specifically, this only seems to apply to mouse movement. Testing in Starfield, just walking around but not moving the mouse, it shows the full 150 FPS or so. But the second I start moving the mouse, the FPS drops down to the more native 90-100 instead. In theory, this should give you the best of both worlds, right? I mean, for just walking around, you get all of that extra performance and smoothness, but when you're in intense combat, it disables itself for that quicker reaction times, right? Well, as far as I can tell, no. I mean, the first problem here is that if it's tied to mouse movement, I can't think of a time when playing, say, Starfield, I wouldn't be moving the mouse, even just to navigate the world. That seems to defeat the purpose of this feature to me. Second, the latency test I was doing was a mouse move. It should have been disabling itself for every test result, but as far as I can see, it stayed active the whole time. Or at least the latency stuck around, whether this is because the OCAT basically instantly shifts the mouse position, giving AFMF no time to turn off first, or because the latency part is just there the whole time, even if the actual frame generation doesn't end up happening. I can't really answer that one, but it doesn't seem all that appealing to me. With that said, the whole point of fluid motion frames is to provide, well, fluid motion. And that's something that is worth viewing subjectively as well as objectively. So let's have a play in Starfield to see what it actually feels like to play with. So we have AFMF on here. So as I mentioned with the whole movement thing, if I move the mouse, we see we're at like 70, 80 FPS. If I stop moving the mouse, we're at 173. So it's a lot smoother now, obviously. I mean, we've almost doubled the FPS. But the second that I start moving the mouse to, fight this Terramorph, that drops away quite quickly. Although it does seem to be the faster the movement, the more it cuts off, which I think might also explain why the whole latency figures were so different. Yeah, see, like trying to dodge this, it drops way down to 80 rather than the like 100 and whatever, 150, 170 it would be normally. Oh, I don't have enough mana or whatever it's called. Star power. I haven't noticed any visual jank yet. Occasionally it feels like it's stuttering as it kind of swaps between modes. That's by far my favorite star power, by the way, the plasma ball. Much better. It's definitely an unusual experience. It goes from being, a decent frame rate at like, 80, 90 to being an exceptional frame rate at like 170. But there is a noticeable difference between the two, and how it decides to cut in and out also can be a bit jarring. Because like right now, even though I'm jiggling the mouse, it's at 170 or so, but you know, bigger movements are like ADSing, it's a lot smaller. But then also it seems if I stay ADS'd, even if I move, it goes back up to 160. So yeah, it's a bit weird. I think it's time to wrap this up with some closing thoughts. Frame generation tech is pretty cool, although it certainly has some drawbacks. On the one hand, it's literally free performance, but on the other, it's a bass-ackward solution to increasing your frame rates. AFMF itself is a pretty clever implementation. The fact that it's baked into the driver means that it works with a bunch of games without the game developers having to do literally anything to support it. That means that regardless of if you want to play Starfield, CS2 or Train Sim World 4, you can boost your FPS with AFMF. The catch is that it only works in DirectX games means that games like Rainbow Six Siege are off the table, although much the same as CS2, you wouldn't want to use it there anyway. Strangely, both with CS2 and with Siege, I had a few bugs where it just claimed I was using an unsupported API when I wasn't and just wouldn't enable. I'm not sure what's going on there, at least with that one, but anyway, the on-off control behavior is actually pretty clever, but it can also lead to stuttering and a bit of a janky experience. Lastly, on the latency front, it's a pretty big ask. Double your latency for like 50% more performance. For some games like Starfield or Train Sim World 4, I can see that being a trade-off that ends up being worth it. But for anything even remotely competitive, there's no chance I'd be leaving this on. Of course, with that said, those are my thoughts, but I'd love to hear yours in the comments down below. What do you think about AFMF and frame generation in general? Let me know in those comments. Also, if you do want to be able to test stuff like this yourself, you can pick up an open source latency testing tool that I developed and make literally at my desk downstairs, available at osrtt.com/OSLTT. Otherwise, if you want to see more videos like this one, you can hit the subscribe button, check out plenty of other videos in the end cards, including those latency guides if this one was interesting for you. And yeah, you can also support the channel with a load of links in the description. I'll leave you to take a look. But yeah, otherwise, thanks for watching. Hope you enjoyed it. We'll see you on the next video.